Okay. So we will solve quadratic equations having real solutions by factoring equations of ax squared plus bx plus c equaling 0. Okay. A couple of things I want to make note of there. What specific part of this equation makes it quadratic? How do I know that this is absolutely without a doubt quadratic? Yes. The exponent of 2. Okay, absolutely. This fact that you have an exponent of 2 here, that is your largest exponent, that is what decides that this is quadratic. Now, the way that this lesson is different from the last couple of days is that we now have a number in front of. Okay, so we're going to have one extra thing that we have to deal with. The other thing I want to point out to you is that when we do eventually get to solving, okay, you can only solve when it is equal to 0. I want to make this point very, very clear, okay? When it is equal to 0. All right, let's go ahead and start with the definition of a prime polynomial. It is a polynomial that cannot be written as a product of 2 polynomial factors, or just 2 polynomials. With integral coefficients. So let me kind of just give you my examples here. Okay. Let's say that I have something like this. I have x squared plus, we'll do 5x plus 2. Okay. So based on what you should have known over the last couple of days, okay, what we have on the top is a times c, and b is for the bottom, right? And when we set it up, that means b, 5 goes on the bottom, 1 times c, that's 2. And we know that we are multiplying 2 numbers that multiply to be 2 and add up to be 5. Well, the only numbers in the world that I can think of that multiply to be 2 is 1 times 2, right? And if I add 1 plus 2, there is no way that I can ever get 5, right? So essentially, you cannot factor this, okay? It doesn't work. It doesn't work. And it cannot be factored. AC goes on the bottom. Okay. Hold on one moment. Let me respond to that. It doesn't work. Let me put that in. And it goes, hold on, I got messed up. Let's see. It doesn't work and it cannot be factored. That's what I try to get for trying to do 2 things at once here. Okay. So this is a prime polynomial, just like a prime number cannot be divided by anything other than itself and 1. All right, that is a really good point, Sonia. I want to bring that up. So I can tell she watched the lesson. When we did the lesson on the prior to, I had to use an older video. Essentially, as long as you remember that AC is the one that you're going to multiply and that B is the one that you're going to add to, the results will come out the same, okay? The reason I had to switch it up when I came here is because there is another method that some teachers use, and I don't know if you've seen this one, but essentially it's where you have an X, okay? And it's the same concept. And so just to kind of be consistent so that when you go to the next level, it's essentially the same. You have A times C on the bottom, and then you have B on the bottom, you have 8 times C on the top, and you're looking to, again, multiply. You need two numbers that are going to multiply here and add up to be this. So they just use a little different diagram, and then they write numbers on the side, but it's the same thing. This I do because it lends itself nicely to being able to factor things with a leading coefficient, which I definitely want to talk to you about. So thank you, Sonia, for bringing that up. As long as you remember, and I like to, so I do this now, I switch it so that it's consistent with what the other algebra teachers are doing when you go to the next level. The other thing is that B on the bottom, I remember that, and then A times C. So I apologize for that inconsistency. All right, let's look at a counter example. So this is kind of something that is not a prime polynomial. And something like that might be x squared plus 3x plus 2, right? Because if you did your little box, and I'm just going to put B on the bottom, that's where we're adding, right? And then A times C on the top, where we multiplied. So I need two numbers. Let's see, 1 times 2, 2, 3 goes there. Two numbers that multiply to be 2 and add up to be 3. What do you think they are? It's really hard, y'all. Only numbers I can think of that multiply to be 2 are 1 times 2. What do they add up to be? 1 plus 2 is? 3. Thank you. So, yep, that works. So you have 1 and you have 2. You end up with x plus 1 times x plus 2. Okay. This can be factored, therefore it is not a prime polynomial. Okay. So let's go ahead and let's continue on. Let's look at example 1a. Again, the difference with what we're going to be doing today as opposed to what we've been doing the last couple of days is that we have a number in front of x, okay? So before, all of our examples just had nothing there or 1, right? Now, just to keep in mind, a x squared plus b x plus c, right? Therefore, a is 5, b is 27, and c is 10. Make sure you always include the sign with the value of the coefficient. Now, let's go into this. So here we have a is equal to 5, b is equal to 27, and c is equal to 10. Nice. I love it when you participate. So I'm going to go ahead here. I'm going to label. I know a times c, b on the bottom. Okay. And a times c is the one where I multiply. This is the one where I add, right? So a times c is 5 times 10. It's going to be 50. And b is going to be 27. Okay. So now if you do have a quadratic with particularly high numbers, I can show you a method to pull up a factor table instead of just doing it, right? What you're going to do is you take y equals, and you always put whatever you want to multiply to up on top of x like that. So you go to your calculator, y equals, let me just clear my stuff out. Okay. And I go to y equals, and I'm going to type in alpha y equals 150 over x and to the right. And then I go to my table, which is just second graph, right? Second graph. And these are all the numbers in the world that will multiply to be 50, right? I'm looking for one that will add up to be 27. Do y'all see one that adds up to be 27? You got 1 and 50, 2 and 25. Skip the ones with decimals or fractions. 5 and 10. Any of these add up to be 27, y'all? 25 and 2. Thank you. 2 plus 25 is 27. So we put that in. And they're both positive. Now, in the prior 2 days, okay, essentially you would be done with the whole process, right? You just plug it in and you're done. Okay, when we have a leading coefficient, we have to use another box. We got the long and tall, and then we got the short and squatty right here. So let me show you how you would set this up. First of all, these two middle terms right here, they are going to go on the diagonal. It doesn't matter which way you have them, but they're going to go right here. Plus 2 plus 25. And you're going to add an x to them. Okay? Easy enough? All right. Then what we do is we take the first term. Here, I'll write it out like this. Basically, first term, first box. Last term, last box. Okay? And so I'm going to go ahead and grab those really quick. Here's my first term. He's going to go right in here. Okay? Then I got my last term right here. And this one is going to go right in here. Okay? So let's drop them in. 5x squared and plus 10. Now what we're going to do is we're going to look for our GCF. It's kind of like when we were like doing that reverse distribution, right? We did a little bit, but we did it with on a smaller scale. We look for the GCF. So when I look at 2x and 10, what is the biggest number I can divide both of these coefficients by? I always start with my smallest number, 2, and I say, can I divide 10 by 2? Yes. So 2 is my GCF there, right? Then, do both of them have an x? No. So now it's like we're dividing. 2x divided by 2 is 1x. Beautiful. Okay, and if you need a visual of that, that's like 2x divided by 2. That cancels out and you get your 1x. Okay. Here we got 10 divided by 2, so that makes this 5. Okay. And then we can kind of work around. Like now, if I looked at this one, what would my GCF be for 5x squared and 25x? I agree with the 5. I start off with the smallest number here and say, can I divide 25 by 5? And the answer is yes. And then do they both have an x? Yes. And what is my smallest coefficient? 1. Good. I'm so glad y'all remember that one. Okay. So then I just say 5x times 1x. 1 times 5, 5. X times x, it's 2. Good, because we're adding those exponents, right? Here we have 5 times 5, 25. And we have the 1x. So ladies and gentlemen, you have factored this. This is awesome. So we're going to go ahead. Everything on the side here is one factor. 5x plus 2. And here we have x plus 5. I'm going to drop that 1. And this is the factored form. See how we do that? Questions? Okay. Can I move on? So I'm going to go ahead. I'm going to scroll up just a little bit. Let's look at example 1b. Now, does anybody notice anything about these coefficients right off the bat? They're big. They're all what? They're all related to 4, right? Look, and when she says related by 4, can anybody rephrase that in a way that they're divisible by 4? 4 is your GCF, right? All of that. Good. So basically, I could, like, right off the bat, make those big numbers a lot smaller, right? And divide everything by 4. Let me pick a color that's not quite so obnoxious. Okay. Divide by 4, and dividing by 4. And that'll make my problem a lot easier, right? So I just have this 4 times, I'm put that out front. And now I just have 1x squared. Can y'all see this color or not really? Okay. And then 24 divided by 4 is 6. Awesome. And then I just have the 1x. And 32 divided by 4 is 8. Yay. And so I just kind of close it up and I don't forget that I have that multiplier 4. So now what I'm going to focus on is this polynomial inside. Okay. What is my new a going to be? A is just the coefficient, just 1, right? B is 6 and C is 8. If any of them were negative, you would totally bring down the negative with it. So we're going to say A times C right here. We got B on the bottom. Remember, we're multiplying for this one and we're adding for that one. So 1 times 8, 8. And we have the 6 on the bottom. I could totally put it in my calculator and say, you know, this 8 over x. But can anybody tell me what are the two numbers that multiply to be 8 and add up to be 6? There you go. 2 and 4. Beautiful. Okay. So the more that you know how to multiply and add, the easier this process will go. Now, because A is 1, we can actually stop here. Okay. Because A is equal to 1, we only need the tall and skinny box. Okay. We don't need the square box. That's only when you have a leading coefficient that's not A, right? And so for those of you who have done the last couple of days, you know you take your two factors from there and you get x plus 2 times x plus 4. And don't forget the 4 right in front. And this is the factored form of this. Does this seem logical, making sense? Maybe you just need a chance to practice, but you got it. Yeah.
Would it be still the same answer even if you didn't divide them? First part?
Oh, if I didn't catch it? Okay. So if you didn't catch it, there's a number of ways that could have happened. Let me go ahead and I'm going to pause this real quick and then I'm going to show y'all. Okay. So that was a good question. Example 2. I'm going to go ahead and let y'all set this up here real quick. Example 2, set it up. Identify your A. A times C, that's the one we're multiplying. B on the bottom, we add, right? We're going to set it up. Put this on pause. Is there a GCF, by the way? No. What do you think is the GCF? Yes. Oh, that wasn't quite the GCF, but okay, go ahead. So you start off with the smallest number, right? 3. Can you divide everything by 3? The only one that ruins it is the negative 22, right? And make it sure that you identify B as negative 22. So yeah, that one kind of ruins it. Can't divide it by that. So basically there is no GCF here. If you need feedback at home on Zoom, just let me know. Okay. I'll pause it. So again, 72 on top and negative 22 for B. So when we're setting up our equation, what number is going to go on top? 72, the number we want to multiply to, right? Our product. And then over x. So again, go to y equals. So you're following along, right? I'm going to clear it, so I have to redo it again. That's alpha y equals 1. Okay? That's the green button. Y equals and 1. And then we type in 72. And we go down. And we type in x. X is located right next to alpha. And we step to the side and we say, does that look like the way I want it to look? Yeah. Then how do I get to my table? Second graph. Okay, hopefully everybody's okay with the calculator. I'm going to pause again. The one box is only needed when A is equal to 1. Today, what is unique about today is that A is not equal to 1 in most of our examples. And so that's why we had to use this long and thin box and then the short and squatty box, okay? So whenever A is not equal to 1, use both boxes. Now, what if your paper doesn't have both boxes? Well, draw it in, okay? For whatever weird reason, it didn't draw it on your copy. I don't know. But you can draw it in because honestly, when you take a test, none of these boxes are going to be in there. You have to draw your own box. So I'm going to make that note under here. We use both boxes when A is not equal to 1, okay? So that's a really good thing, okay? So I'm going to go in here. We went to y equals. Most of y'all put in the 72 over x, right? Second table. And we went up for the negatives. I got -1 and 72. That's too big. -2 and -36, still too big. Too big. But -4 and -18, just right. And if you're not sure, you can do this. -4 plus -18. And you get -22. These are our two numbers. Any questions on that? Okay, so that's going to go right here. -4x, right? -18x. First term, first box, what goes right here?
24.
Good. And last term, last box? 3. Okay. So I'm just looking at the 3 and the 18x. I'm thinking that looks kind of easy. Maybe I'll try that one. I'm also noticing I got a minus. Let's see. Well, you know what? I want to do this one because I've always kind of stuck to the easier numbers. Let me kind of show you when we have two kind of numbers that are a little bit more complicated. We got 24 and -18, right? So if I'm trying to come up with a GCF for those, I'm going to pick my smaller one and I'm going to just leave off the negative for a second here. I got 18. And my factor table would be 1 and 18, right? 2 and 9. 3 and 6, and 4 doesn't go, and 5 doesn't go, so there we are. So what happens is I start here, and I work my way around, okay? So can I divide 24 by 18? Not nicely, no. How about 24 divided by 9? Not nice. It kind of ends up like a decimal. And then let's try 24 divided by 6. Yay, that's a winner. Okay, we get 4. So I'm going to go ahead and pull out the 6, okay? And they both have an x to the power of 1. Any questions on how I got that GCF? Okay, what's going to go up here? 4 and x. Good, very nice, okay? And then what's going to go up on top here? -3. Good. Now, if this is -3, and this is +3, what's got to be over here? You're so close. -1. Because what you're saying is 3 divided by -3 is, and you could put it in here if you needed to, -1. Or you could say -1 times -3 is +3, right? And does it work for this one? Absolutely. -1 times 4, -4, and you have the 1x. So ladies and gentlemen, I kind of double checked for any GCFs that I forgot. No, don't really see anything. And ladies and gentlemen, your final answer was 6x minus 1 times 4x minus 3. What if you ended up with them switched with 4x minus 3 times 6x minus 1? Is that okay? Yes, it is good. Okay. All right, ladies and gentlemen, we're going to take a little break. Okay. We're going to break for the day. So if you need more practice, definitely the lessons that are posted right now will give you the practice that you need on this, okay? If you have a question, stick around. Other than that, have a beautiful day.